boom. All right, folks, so welcome again. We're continuing with our videos in the CSEC AdMath syllabus. In this video, we're gonna use an actual example of the equation of a circle. We'll use a real circle then, right? We'll use a real circle and we'll do some things with it just to demonstrate how we do the thing. And then, of course, the next step after that will be to do some actual practice. All right? So we will give sufficient examples, sufficient opportunities to practice. Well, this will be the main example, and then after that, you practice, and then we 5, 4, 3, 5, 4, 3, 5, 4, 3, 2, 1. 5, 4, 3, 2, 1, 0, and boom! Whew, pressure, boy. 5, 4, 3, 2, 1, 0, and boom! Yes, folks, Hume again. So, welcome to another one of our videos where we make our way through the CSEC AdMath syllabus. We continue with our series where we talk about 5, 4, 3, 2, 1, 0, and 5, 4, 3, 2, 1, 0, and boom! Yes, folks. So, welcome to another video in this. All right. Five, 4, 3, 2, 1, 0, and boom. All right. So welcome to yet another one of our ongoing series of videos where we dealing with topics in the AdMath syllabus. In this video, we continue in our series where we talk about the equation of a circle. So let us choose a random circle. Let us say, for the sake of argument, that the center of our circle would be the point, let us say 6, 7, and the radius of our circle. The radius of our circle is 6, 7, and 8. Let me say 8, just for the sake of argument. 6, 7, and the radius is, no, let me leave the radius as 5, all right? And the reason why I'm doing that is because I want to make it easy for me to sketch it, just for the sake of illustration, right? Now, you don't actually need to see the circle to do the question, all right? You don't actually need to see the circle to do the question. But if you have the ability to visualize it, then no problem. But if not, then you just work through the algebra. Of course, this is where your practice would come in, because this is not something that you could just pull out of a hat in an exam. You really had to practice before. All right? So we have the important information. Now, let me say a couple of things before we proceed. Anytime you're dealing with a circle, whether you're doing it at AdMath level or you're doing it at Cape Pure Maths level, in the Caribbean context, or any other context that would be of a similar level or maybe a higher level, the two bits of information that actually define any circle would be the center and the radius. Any circle you could think of on a Cartesian plane, you had to know the center, one, and you had to know the radius. Once you have those two pieces of information, you could find out anything else. You could find the circumference, you could find the area. And of course, you could find the diameter, which is just 2 times the radius. So once you have the radius and the center, your business fixed. Where the circle is concerned And then, of course, you could use that knowledge to do other things as the circle interacts with other points and lines and shapes and whatever. So we have the center 6, 7, and the radius 5. If I have to draw that on a pair of Cartesian coordinates, this is what it will look like. All right? So let me say 1, 2, 3, 4, 5, 6. And let me say 1, 2, 3, 4, 5, 6 are coming up here. All right? 7. So the center will be somewhere here. And if the radius is 5, then this is 6. So we have 1 here and 2 here. All right. So that circle will be somewhere here, like this. All right. Okay. Let me draw this somewhere else. All right. Now again, you don't have to go through all of this in the context of an exam. So I'm going to leave up my travails with the graphing of the circle just to make the point that the graphing of the circle is not an absolute necessity, but we go draw it still, right? So 1, 2. Now I'll need some more space. We need one quadrant here. Notice I'm using some specific vocabulary, right? I'm talking about quadrant and thing. You could deal with that in more detail when we start to do the trigonometry later in section 2. But for now, 1, 2, 3, 4, 5, 6, 7. Come. 7, 8. 1, 2, 3, 4, 5. There's a 5 there. 6. 1, 2, 3, 4, 5. 5 right there. 6, 7, 8. And we're going up the road. That's your y, and that is your x. All right? Okay. So if we have to graph this, this would be 6. Let me see. 6 would be. Going up the road. All right? Come line. Stay straight now. And then the 7 here would be, you're coming across. So that's the center of the circle there. And if the radius is 5, then this is 7. And this is 6. So it would be something like this. All right. I still managed to get myself in a situation where I don't even have the whole circle on the board, but you get the point. All right? You get the point. So that's your circle there. All right? Again, I want to make the point. I want to repeat that it is not necessary in the context of an exam to draw the circle. There may be questions where they actually give you a circle and you have to use that circle to solve a problem. But usually, it is not the case. It is not usually the case that they actually require you to draw a circle in an ADMATS exam. So don't feel that you have to draw a circle. No, you don't need to draw the circle. However, it is good to be able to visualize the circle. And the standard form allows you to do that immediately. So when we get the equation of the standard form, one line and you're done there, you know. If they tell us that the center is 6, 7, and the radius is 5, and they ask us to write the equation of the circle, problem done right there. All right, so the equation of the circle is, watch it now. The equation would be x minus 6 in brackets squared plus y minus 7 in brackets squared is equal to 5 squared. All right? That is the equation of a circle. Now you could choose to put this as 25 if you want, but I will leave it like this just to reinforce the point in terms of it following the general form x minus q all in brackets to be squared plus x minus p all in brackets to be squared plus y minus q all in brackets to be squared being equal to r squared. Your problem done right there. Your problem done right there. All right? So what we're going to do now is use this form, do the algebra, and derive the general form. And then, having derived the general form, we will then go into that and get the center and the radius using the relationships that we would have discussed in our previous video. So we're going to rub off the graph now. We don't really need it anymore. We didn't really need it at all, but sometimes you had to put information that may seem to be unnecessary just to make the thing a little more vivid. All right? Of course, in 2020, we have a whole lot of different programs and software online and offline that will allow you to draw any circle you want. All you need to do is enter the coordinates of the center and enter the length of the radius, and boom, circle. So that is something that you may be interested in as well as a student in the 21st century. All right? So we have here the standard form of the equation of a circle. Right? In one line, once you have this, boom, your problem done. Yeah? That is how straightforward it is. All right? It doesn't matter whether the coordinates are negative or positive or whatever it is. This is what you will end up with. All right? So just for the sake of argument, if the coordinates were both negative, if we had, instead of 6, 7, if we had minus 6, minus 7, then in that case, the equation would be x minus 6 in brackets, right? Let me put it in square brackets, plus y minus 7 in brackets squared. The radius will always be a positive number because you're actually measuring the length of a line segment. So you'll never get a negative radius. All right? Being equal to 5 squared, in which case x minus 6 is x plus 6. X plus 6 squared plus y plus 7 squared being equal to 5 squared. So you could also get the equation with a plus sign in the middle here. All that means would be that your coordinates, the respective coordinate is negative. Whichever one is positive here, or if both are positive, then you will get either one of these being negative or both of them being negative. But let us, for the sake of simplicity, stick to 6, 7. I am pretty sure you'll get some of these with one or both coordinates being negative in the practice examples. So, we move forward with these guys here. So remember, to move from standard form to general form, we just proceed with the algebra. So we expand. And again, I'm writing it out in one shot. X squared minus 12x plus 36 plus y squared, we expand this here now, minus 14y plus 49 is equal to 25. So we know we could expand out the 5 squared, and we bring everything together, we get x squared plus y squared, right? Minus 12x minus 14y, 36 plus 49. Okay, let me just put everything just for clarity, plus 36 plus 49, and I bring the 25 across, and I get minus 25 is equal to 0. Now, look at what happens when we actually work out the value of this. All right? You will get that the equation would now be what? X squared plus y squared minus 12x minus 12x, yes, minus 14y. We could add all of this and get one number, one constant, the big K that we would have mentioned in the previous video. 36 plus 49 is how much? 9 and 6 is 15, 3 and 4 is 7 and 1, 8. 36 and 49 is 85, 36 and 50 is 86, minus 1 is 85, right? 85 minus 25 is 60, plus 60, boom, is equal to 0. So this is what you would see if we had to get the general form of the equation representing this circle to start with. So in other words, if you were in an exam or in a practice question or in some other context where you're using the equation of a circle, you would have gotten this to start with. You wouldn't, let us assume for the sake of argument that you got this without this information here. So what I'm going to do at this point, having gone through the algebra from here to get to here, we're going to erase everything here and continue from here as if this is what we had started with to begin with. Yeah? So we erase it now. All right? And we continue. So let us, for the sake of argument, say that this is what they gave us as the equation of a circle, and they ask us now to find the coordinates of the center of the circle and to find the radius of the circle. Now, once you remember the relationships that we had from the last set of working, you know immediately that you could say, let us see how we write this. You could say, let center equal P, comma, Q. All right? So you assign two variables to the center. P, Q, A, B, F, G, X, Y. No, you're already using X, Y for the circle. Whatever two letters you want to choose, you run with that. Just make sure you keep it consistent. Right? We know that P is equal to a half of whatever the coefficient, minus a half, sorry, of whatever the coefficient of X is. The coefficient of X here is minus 12. So P is minus a half by minus 12. Minus half by minus 12 is, guess how much? 6. And we know that Q is equal to minus a half by whatever the coefficient of Y is, which is minus 14. And minus half by minus 14 is, guess how much? 7. So therefore, the center is equal to 6, 7. All right? Now that we have 6, 7, remember in the next relation as well. Remember that 60 would be the x coordinate squared plus the y coordinate squared minus the radius squared. All right? So if we want to find the radius of this circle, we could say that 60 is equal to, let me start general, P squared plus Q squared minus R squared. All right? P, of course, being the x coordinate of the center, Q being the y coordinate of the center, and R being the radius. We know that P is equal to 6. All right? So we could say that 60 is equal to 6 squared. We know that Q is equal to 7 plus 7 squared minus R squared. So now we have a situation where we could actually find the value of R. So 60 is equal to 6 squared is still 36. 7 squared is 49 minus R squared. So 60 is equal to this plus this is 85 plus R squared. And of course the R squared, sorry, minus R squared. Oh, I get worried there, boy. So you take the minus R squared and you bring it across here. So R squared, and then you take the plus 60 and you bring it across here. So R squared is 85 minus 60. R squared is 25, which means therefore that R is equal to the square root of 25, which is equal to our good friend 5. Now, of course, common sense would suggest that you don't even consider the negative value of the square root here, because the negative value of root 25 has absolutely no meaning in the context of finding the radius of a circle. The radius of a circle, of course, being an actual physical measure, a real number, as we would say in discussing different types of numbers. So let me make this R properly here, because sometimes I do get into trouble for my calligraphy. Calligraphy refers to different styles of handwriting. Calligraphy. You see, you're getting vocabulary in the ADMAT session. Couldn't want it better than that. Nice? So, watch it. Radius is equal to 5. Right? So, we started with the general form, and using the relationships that we would have derived previously, we were able to extract the same information for the radius of the circle and for the coordinates of the center of the circle. The moral of the story is that it doesn't matter what form of the equation you use. Once you know what to do with it, and you do it without making mistakes. Of course, to get to that point requires some practice. All right, so the first step is understanding. Understanding the concept, understanding where things come from. That would have been the purpose of all the videos on the equation of a circle from the start to this point. And I want to use the opportunity now to give you the strongest possible encouragement to move to the next point, the next stage, the next step on the journey, which is practice. 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 Do not take for granted the importance, the absolute necessity to practice the easy stuff. So make sure you do enough questions practicing the standard form of the equation of a circle to get it rock solid. Then make sure you could move from the standard form to the general form. Right? Make sure now that you could take the general form of the equation of a circle, just as we did here, and extract the key information, which would be the radius of the circle and the coordinates of the center of the circle. All right? And once you could do that, you would have put yourself in a position where you could now go further and deal with situations where the circle is not just a circle in isolation. All right? So you move past the point of just finding the radius and the center of a circle. You now could get to the point of dealing with the circle interacting with other entities. All right? The circle interacting with a straight line, as would be the case in the ADMAT syllabus. The line might actually pass through the circle. To cut the circle, the line might actually be a diameter of the circle, which is to say that it passes through the center of the circle. The line could be a tangent to the circle. The line could be a normal to the tangent. which means that it would actually be a radius or a diameter, depending on how you want to consider the line segment. Right? At K pure mass level, you would actually have to deal, apart from dealing with circles and straight lines, you might have to deal with two circles interacting with each other. It's a different level of the algebra. But you wouldn't have to worry about that unless you decide to do K pure maths, if you decide to do that. All right? But all of that aside, I trust, hope, and absolutely believe that all of the discussion that we would have had from the start of the circles discussion to here would have been beneficial. In other words, we're not going around in circles, right? We're moving forward. All right? And I want to encourage you to keep working. Don't neglect your work. Don't ever forget that maths is not maths. So even when you feel you understand, even if you watch the videos and say, hey, I know what to do, don't fool yourself. You need to practice, you need to go through the steps, the rhythms, the rigors, so to speak, so that when you find yourself under the pressure of an exam situation, you can reproduce whatever you need to reproduce and get whatever you need to get without making a mistake. So, as always, keep viewing, stay in the game, keep practicing, and look out. We have plenty more coming your way.